So yeah, hopefully everyone will learn something from this, and I'm excited to be doing this. So get me started.
Yes.
Daddy, want to start?
Yeah, sure. So I have a background in mathematics. I was really big into data science and AI. I mean, I still am. I'm doing my dissertation in applied math, so that's my background. Um, Coming into Web3 right now was a decision to kind of get ahead of the curve because after my dissertation, after I have my PhD, I want to go into it full time. So jumping in a little early was my way of getting a head start. And coming from a mathematical background, I didn't really do much in coding. Like I did a lot of coding, but pure computer science. And so I wanted to dive into gas optimization and Yule and all this assembly and so forth because I had no background in it, and I knew it was a big thing. So that's where I began.
Awesome. Nice to meet you, by the way.
Really cool.
So I'm Ars. I started with programming 6 years ago. I started with Python, which introduced me to programming, and then I learned JavaScript and web development. Spent some time on Web 2 as a full stack web developer, but I knew I wouldn't succeed because of the competition. So I decided to move to Web 3, which was like 2 years ago, probably more. And yeah, I learned Solidity and Web 3 development. And the last year, I was just writing smart contracts, working on some projects, doing websites too. And then I decided to learn auditing and lower level Solidity. So this year, I decided to transition to auditing and started auditing like 2 months ago, like doing contests and all this stuff. And you might know me from Twitter, where I post a lot of gas optimization tricks and stuff related to that. And today we will be talking about it. So, for those that don't know, the goal of optimizing gas is to reduce the overall number of operations needed to run a smart contract. The first thing we'll talk about is just about our journey, how we learned how to optimize, and how you could learn how to optimize. So I'll start. I decided to learn how to optimize when ERC 721A first came out, and that's when everyone started really caring about their gas usage. So I knew that I had to learn how to optimize if I wanted to be a good Solidity developer, and it's just a skill that all Solidity devs should have because your users pay money when they interact with your smart contract, and just I really liked what they were doing. And at that time, I knew Solidity quite well, but I didn't really know much what is happening behind the scenes. So I started learning how the EVM works, and I started to understand more of what is happening and what and where you can optimize. And I started small, and I was writing gas optimized NFT contracts, which is great at that time and something new too. But you have to start small. And then in summer, I bought the Jeffrey Schultz gas optimization course, and I took the course. It was amazing, and I read many articles, watched many videos, but I learned the most when I was just writing some functions in Remix and just debugging the transaction and understanding what is being done here and just going through the opcodes one by one, understanding what every opcode is doing, how this stack is manipulated, how does memory and storage work, and stuff like that. And that's when I really started to understand how the EVM works and why something is cheaper than the other thing. Like, for example, the 22 gas difference because of the function dispatcher. And I just understood why, for example, using call data is cheaper than memory. And I spent a lot of time in the EVM codes playground, just understanding how everything works and seeing how the values are pushed to the stack and stuff like that. And then I also did the EVM puzzles and the rare skills gas puzzles, which definitely helped me a lot. And also reading the code of some protocols helped me a lot too. So I learned how to optimize in Solidity, but I wanted to go like even deeper. So I decided to learn Yule, and Yule is not easy, and I still haven't mastered Yule. I don't know HUFF or Viper, so still far away from being a good optimizer, but I definitely plan to learn both. And yeah, that's how I learned how to optimize. And my first ever submission of a gas report on Code Arena earned me over $200, which is just great from gas optimizations. So yeah, Dad, you wanna talk about your journey, and then we'll talk about how you would learn this if we had to start from the beginning.
Yeah, thank you for that, Ars. Yeah, so I came into the space as an investor to begin with. So gas optimization is something that I kind of gravitated towards naturally, as you know, as an investor, and you got to spend all this gas minting an NFT or whatever, and I just knew that it was going to be a big thing for specific protocols, since it actually is a key deciding point for some people, for a lot of people, whether they will participate in a protocol or not. And so I knew that it was going to be something I wanted to focus on. How I actually started my journey was just making a Twitter. I just made a Twitter, and I went to ChatGPT, went to all the docs, whatever, taught myself what I could, just doing that, and started making posts, and a lot of them were wrong. Some of them were right, but a lot of them were wrong, and people corrected me, and just learned along that way. And that's actually when I met Ars. And that's where I got the big boost of this gas optimization, and he really put me on game for the actually looking into the depths of it all, and going through these opcodes and all these playgrounds and the debugging and remix and all of that. So yeah, and then now I'm here. I haven't really dived into Yule too much. I do know, as I said, I have been getting into it, but like Ars, there's a lot of room for growth there. But yeah, let's get into what everybody can do to get a little better at this, and what some of the key errors are.
So I think the first step that everyone should do is learn how the EVM works, and I think we can agree on this. Just understand where information is stored, understand what the bytecode is, what opcodes are, what is a function dispatcher, and many more other stuff, right?
Definitely. I mean, I think the biggest thing for me was fully understanding what the EVM is doing. I think that was one of the largest hurdles for me, especially in security, but definitely in gas optimization too. And the coming from a background in Web 2, a lot of people, I see it even in these experienced devs, they'll be assuming things are changing or whatever. The transaction hasn't been gone through, the block hasn't been printed, and so forth. And it's hard to get out of that mindset that a line of code is ran and something's changed. But yeah, so that was my biggest hurdle, was learning the EVM and kind of transitioning from that Python mindset into Solidity.
Yeah, definitely. So as I said, read articles, watch videos, read the yellow paper, but the most important thing is that you try it yourself and actually step through the opcodes yourself. And yeah, as I said, that's what helped me the most, and that is when you will actually understand how the EVM works, and you will be able to tell what a function will do, what opcodes will be used, and how much gas will that opcodes cost, and stuff like that. So, and once you learn how the EVM works, you will just see where gas can be saved because you understand how much the opcodes cost, and you will sort of have this vision and understand what is expensive and what is not. So I would say two great tools, Remix and EVM Codes. Just really recommend everyone trying them. Really amazing stuff to actually learn and see how the EVM works and all the opcodes. And definitely EVM Puzzles. It's a very cool game where you basically have to basically you have to pass in the correct value or the correct call data so that the function doesn't revert, and it's a really cool way to learn.
EVM Puzzles, I don't think I've done that one. So it's like what are you doing there? So you're putting in the right.
Basically you have opcodes, and then you have a jumpy opcode, and you need that jumpy opcode to jump to the jump destination to the jump destination so that the function doesn't revert. I'll send you the link here. just quickly.
That's pretty interesting. Miss, have you heard of this?
Yes, it's a CTF, kind of a puzzle CTF you do to learn the EVM, the internals. This is really interesting, really good one.
Yep, thank you.
I think this is really what you guys are saying. I mean, coming down to learning the EVM is one of the most important aspects. And the EVM seems so complicated until it gets simple, you know. Like, I don't know how you guys feel about this, but it's really hard for me to interpret the program counter. So when I'm looking at the assembly instructions is really hard for me. You know, you also is really hard for me to grasp my head into that. There's any kind of tricks or I think just practicing, right?
So for me, one thing that really helped was, as Ananda said here, building your EVM from scratch. And it in the I think Alchemy University was the one. I don't know. I did quite a few of those, but I believe in Alchemy University they go through even not really building your own EVM fully, but for the most part, you'll understand JSON RPC requests and like actually like making these objects of the block information, the transaction, and so forth. And then after that, at least for me, it became a lot more clear. So I would recommend, I believe it's the Alchemy University for that.
Really nice.
Yeah, so definitely check out those EVM puzzles. It's a really cool way to learn. And if you don't know, if you have problems with the program counter, then you can just check out the playground of EVM codes, or just the remix debugger, or the Foundry debugger. So the second step, I would say, learn some tips and tricks, right? There are many tips and tricks that are definitely good to know, like, for example, caching the array length and sort of this stuff. You know, you'll never learn every single tip, but just try to see how the best protocols do it and do it the same way.
Nice,
What really
buddy.
helped me was, oh, sorry, go ahead, Miss.
No, this is really nice. I mean, and can I ask you guys something? So ours was saying that for his wake up call for gas was ERC 721A, right? Ours.
Yes,
S-
C721A, yeah.
So what was the big difference in there, and how much of a gas saving you had from this contract to a classic NFT?
Basically the Open Zeppelin one just loops and mints each token, and basically the ERC71 batch mints them and stores all the tokens for the one owner. And yeah, the gas costs were really big for
You know, it was
the
interesting.
Open Zeppelin. Yeah.
Sorry to cut you off there, Ars. I was just saying it's interesting because I was one of the looking into ERC 721 versus 721A. It was one of the first times where I was seeing like the complexity in the gas, specifically in that, it depends on which project you're using, right? Which one you want to use, 721 or 721A. If you have a project like Azuki or, Bored Ape, where you potentially will have a lot of people, minting, like Ars is saying, batch minting, then obviously you want to do 721A. But if I remember correctly, the 721 was more gas efficient for single mints. And so, you have to take all of this into consideration with these protocols.
Yeah. And also I think the transfers, when you transfer the token, was also cheaper for the Open Zeppelin one. But yeah, and then the third step, I would say, learn you. That's how you like access the EVM's fine control, and yeah, that's how you really eliminate gas and unnecessary opcodes.
Really cool. I'm inviting more people to speak, so if they have questions, they can just open their mics. And
Sounds
and
good.
and guys, today there's a lot of talks regarding so gas is really important, right? Everybody's looking at it. It is getting more and more complex, and there's the awful question about gas versus security. Where
Yeah,
you
we'll talk about this
yeah, so go on.
just probably on the end, or like. So we wanted to talk about also the fourth step. I would say just never stop learning and just think. A lot of optimizations come from thinking. Just think about the architecture and stuff like that, and just never stop learning. I don't know every single gas optimization that exists. On the contest that I was auditing, I found some optimizations that I never thought about. So just the only way to find out is to benchmark and test.
I would also mention the game has kind of changed a little bit with the bots, the automated guest finding and so forth. I think they're great personally, but that's not the point of what I'm about to say. In that a lot of these things like caching your array length, do while versus for, transfer from not being checked, etc. All these things are going to be found by these automated bots, and that's fine. So if you're in it for your own little private audit thing, then obviously you need to know it all. But if you're trying to get the bare bones and you want to actually make some money and make it fun to begin with, I would focus with things that bot's not going to find. And that's honestly going to be a lot more creative. It's not going to be scanning for something that some regex or some ast can find. So you're going to really be looking for, is there a way for us to delete a line somewhere, right? Are they writing to storage 3 different times and it's all the same thing? You're looking for redundancies in the code. You're looking for potential bit shifts that weren't caught by the bot and so forth. And it's a lot more fun, I think, but I just wanted to throw it out there. What do you think about that, Ars?
100%. We'll talk about, I'll sort of just share my auditing process, but, if you can just find a gas optimization without understanding what the code does, it will probably be found by the bot too. So you really have to understand like what is being done there, and just I remember when you posted like a gas golfing challenge and it was like a for loop, and the for loop basically performs some math, right?
Mhm.
And basically people like me thought, okay, I'm gonna optimize this loop, but the solution was to rewrite the whole block and just remove the loop. So that's exactly what you should be doing, not just focusing on these small optimizations, but actually rewriting, right?
Indeed.
Yeah, so now let's talk about how to write a gas optimized contract. I think you should start with an efficient architecture. So you have to spend a lot of time thinking of an efficient architecture. Like, for example, the blend from Blur that was written by the GOAT transmissions. And basically, the blend contract minimizes how much data is stored on chain, and significantly reducing the number of expensive S stores and S loads. For example, the loan data is not stored on chain. Instead, the contract simply stores a mapping of loan ID to loan hash. And yeah, just remove what's unnecessary and reuse code. And the second thing I would say, do more what is cheap and less what is expensive. So if you can rewrite or organize your code so you're doing more what is cheap and less what is expensive, then you're saving gas. And there's sort of 2 levels of optimizations here. The solidity stuff, like using memory and storage in the correct way, and the assembly stuff, like really eliminating unnecessary opcodes and rewriting big loops, to assembly. And every optimization here will just have a reason why it's cheaper here. And the third thing, just search for those tips and tricks. This can obviously be automated by some bots. And just, for example, pre-incrementing, which, by the way, doesn't work if you compile it with the VIR. So the compiler is sometimes a bit lazy, but again, it's not your excuse not to optimize. And number 4, I would say, just always test, try, benchmark, see what's better, and rewrite. Ed, what do you think? Is this a good way to write a gas optimized contract?
I think that's a great way, personally. I would always say to So if you're okay, so I don't really know. I'm guessing this audience is more auditors, but I'm going to speak from like a developer's standpoint. If you're developing a contract and you want to do your gas optimization and you know some things, but you don't know a lot, that's fine. I would just rewrite that function in about as many different ways possible. That's what I did, at least when I was learning. What does a do while do? What does a for do? What if I do this, that? What if I start pre-increment and so forth? And if you just do that with your contract that you're developing, you're eventually going to find at least a more efficient way than what you had in the beginning. So yeah, I just wanted to throw that out there.
Yeah, definitely. So let's maybe talk about how to actually audit a contract. We talked about how to write a contract. Now we'll talk about how to audit the contract and find some gas optimizations. So you want to share some stuff about this?
Yeah, sure. So, I mean, the auditing process is obviously going to be different from person to person, but I've studied actually quite a few, Patrick Collins, Bytes 32, I think Ethan Trust. It's a few of them. I've looked at their Twitters. I've read their reports, and no matter what, there's always one key thing that every auditor is going to do, at least at some point, and that is understanding the protocol, right? So you got to go into Code Arena. You got to read whatever's on that GitHub. You have to read all the docs that are in there. You have to go to the Code Arena Discord. You have to open up that one for that specific contest. People will be asking great questions, and these questions are coming from somewhere in their mind. So keep that in mind. And yeah, you're just going to have to understand that protocol at some point. So that's the point I will make.
Yeah, definitely. That's always the first point. Even if like you're doing a gas audit and not a security, just understand the protocol. As I said, if you find the optimization without understanding the protocol, then it was probably already found by a bot, so you won't really earn much from it. And just then you can then you just you see what is expensive, what is cheap, and just rewrite. And optimizing is good, but like you also have to rewrite, and that's how you also optimize. And then just benchmark, right? Just see what's better. I use the Foundry gas report. You can also use the Hardhat one. And yeah, and number 4, just write the report. This is very important because Code Arena only selects the best reports, and just really spend a decent amount of time just writing the protocol. You should have like a good explanation why you think it's cheaper, and a good recommendation, and all the instances, and just how much gas was saved. And just you won't earn much if you just submit like a few gas optimizations. You have to have a good quantity of gas optimizations and a good quality report. So yeah, that's my auditing process.
Yeah, definitely. If I'm focusing on the gas, I think I've already told you guys, basically looking at what's being instantiated twice. Are we doing things that we can be bit shifting? These kinds of things. But your biggest gas optimization is going to be something that you rework, right? So something where like the for loop or something in general can be massively changed. And so that's what I'm usually looking for. And of course, you can't change the functionality, and you can't introduce bugs. So you can't change a whole lot. You got to make sure you're really careful with that. But yeah, so for the auditing process, though, I look through. I make sure I understand the protocol. I go through each script very briefly, very fast, running through it, and then lastly, I will go through and line by line do exactly what ours is talking about. Rework it, figure it out, see if there's anything I can optimize.
Yeah, 100%. So let's talk about the current state of gas optimization and what does the future hold for this field. Right now, it's a quite new field and a very interesting one too. Just gas audits are kind of new, right? But it's great that some protocols care about the users, and not even about their users, but the users of the whole network. And why don't protocols optimize? Is it because of readability? Is it because of security? What do you think?
I think readability has a lot to do with it. I've seen projects just straight up reject, doing these gas optimizations because of readability issues. And it was something I even struggled with, a little bit myself. But I think that beyond readability, it's more so right now that it's not paid out, right? You go to Code Arena, you go to Sherlock, and you get like this $100,000 prize pool, and 1,000 of it's gas, and you got 50 different people competing for that. So a lot of people probably just skip over it. A lot of people will see those numbers and think it's not important. There are a lot of private auditing people coming out. I know Harrison was doing something good there. Of course, you have ours here and myself focusing on this. So there are people that care about it, but that's what I would say.
Yeah, definitely. But most gas optimization don't even have to come from Yule. So I think that like when you rewrite to Yule, then okay, that's kind of understandable that there's a security risk. But some gas optimization don't even have to come from Yule, and sometimes the devs are just lazy to optimize, and it can sometimes improve the readability, but sometimes it can. I agree with that, but like it shouldn't be an excuse for devs not to optimize, right?
Mhm.
And we have seen some protocols being optimized, and some protocols like Earn or Curve, even rewritten to Viper. What do you think? Will we see more protocols being optimized?
I think so. I think in the future it's inevitable as we get closer and closer towards actual adoption of this, mainstream adoption. Then we're going to have the kind of coalescence of some sense where a lot of these protocols are essentially going, at least I think this is what I'm thinking, a lot of these protocols are going to kind of be converging and so forth, and a lot of them are going to hit the wayside, just like any startup market, any kind of emerging market. All these excess ones will hit the wayside, and these ones that are left standing will need to optimize, or else they're going to be pushed aside. That's what I'm thinking.
Yes, I think that the same. Though many protocols that exist today can be significantly optimized. But the question is, when Ethereum scales, will the devs have to worry about optimizing their code or no?
That's a good question. Not entirely sure. But we do have a question here from Ronan in the chat. Ours, if you want to hit this one, he's asking, would like to know what are some of the ways and process for someone to do these gas optimization reports and these qualitative analysis reports for a contest for a newbie.
Yeah. Okay. So just I know that Code Arena and also Hats Finance do these gas that you can submit, and just basically I did Juicebox, and I just submitted the gas report, and I earned a quite nice reward, right? And just as I said, we've mentioned how we should learn, and if you want to, like, as I said, first understand the protocol, as you would do with when doing security, and just the bots are getting quite good, so you're not gonna find these small tips and tricks. So just find some code that isn't used. Find code that can be rewritten into a cheaper way. We have to understand what is cheap and what is expensive, and then do what is cheap. And just as we mentioned, you have to rewrite, not optimize, and just benchmark, use Foundry, test, see what's better. And I said that I didn't even know about the gas optimizations that I found. So you just have to go one line by line and just see what can be done here.
Yeah, and some tips in general about like the process of auditing. I've gone through a different set of ways of auditing these protocols, and one thing that's really helping me right now is Markdown. So if you don't know Markdown, definitely would learn that. And it's just been really easy for me to take notes, to like keep everything a little bit more organized while doing all this, especially when you're doing gas optimization. You have all these gas reports and everything. It can get a little out of hand. And having a nice organized pre-report can really do a lot of good. In fact, I just read a tweet from somebody quite prominent in the space. I'm drawing a blank right now, about how they made some comment, with two little words there. They're sitting there for 2 hours trying to figure out what they saw. And you want to make sure you avoid that and do a proper job with your pre-report.
Yeah, I think like the report for gas really matters. As I said, Code Arena only selects the best reports, so that really matters. You can't just submit a few gas optimizations. You have to submit a lot of gas optimizations and actually show that you're saving gas and provide a reason why it is like that. I can also send you like my template for the report later, just for someone to learn. And yeah. So about the Ethereum when it scales, I think that devs will still have to optimize their code, and the reason is simple, and that is because of the transaction computation power. And so the more gas your function costs, the less you can do in a single transaction, right? And just every time I tweet gas optimization, people are like, why the fuck would you do this if you can just use a layer 2 chain? And I will say that because of the transaction computation power. So that's what I think.
Most definitely. I thought you were more referring to, like how all this, for example, right now the optimizers and so forth are kind of, we're slowly but surely, as these Solidity versions get higher and higher, edging towards the area where it's doing a lot of the work, right? And a lot of this gas optimization that gets done, a lot of people will even argue is, Solidity's mistakes, right? The devs are kind of making up for the mistakes of the development of Ethereum. Is what their argument is. And so, I thought you were going on, what if there's no more mistakes? What if you can just have a dot length in the no caching of the length of the array, and it just figures it out for you?
Yeah, definitely. I'm also excited to see new opcodes that will be added, and like we've seen with Push Zero, or when we might finally have transient storage.
Right.
So I think we can discuss some ideas come to gas station, and I have a lot of ideas for projects that can be built that can help developers optimize their code. So, for example, everyone's focusing on security right now, but gas optimizations are kind of overlooked. And for example, we have Slither, right, for security, but I didn't see anything like that for gas optimizations, like a tool that everyone can use. There are obviously these bots on Code Arena, but there isn't like a tool that everyone can use. What do you think? Would that work?
That's difficult because, well, I mean, that's a really good question. I would say something along the lines of there might be like incremental innovations on these like gas reports like Foundry and Hardhat, but it's really hard to make a tool that doesn't fix it for you. You know what I'm saying? It's already going to recognize that there's an issue somewhere, and unless this tool does some kind of reworking for you, moves lines around and so forth, like almost like a fuzzing type thing, maybe, but yeah, I would just say it's probably going to be very difficult.
Yeah, I mean, it can be done for like these small tips and tricks, and I would love to see a tool like that just for the small tips, right? But it's not gonna optimize like a bunch of code, right? Like a person would do, and that understands how the EVM works. And we also have Immunify, right? But like, would a bug bounty or a gas bounty platform work?
Gas bounties definitely sounds like a good idea. I think personally, I'm surprised they don't have it already. And I'm really surprised, honestly, by the lack of love that gas gets in the Code Arena and Sherlock contest as it is. But yeah, a gas bounty, and I think the biggest problem, as I'm saying this, The biggest problem is that it's going to cost these protocols money, and they're not going to get anything right off the bat from it, you know? Security, it's pretty obvious why they need to secure this, and even just having an audit from Code Arena will entice the investors, things like this. So you really have to find a way to motivate the protocols to do it, is where I'm getting at. And I don't really know where we're at with that.
Yeah, definitely. And you don't like help only the users of your protocol. You help the users of the whole network, right? And I think it would be cool if you had like a gas bounty platform, but there should be some ways so people don't submit like just these small tips and stuff like that, and submit actual like results. So I think we can answer questions.
Yeah.
Awesome, brothers. I mean, that's great explanation. I really love what you guys are doing here. Okay. One question that I have for you is today there's a little bit of a fear of using things like HUFF on production with deployed contracts. You guys see a future where we're going to start doing that more?
So with HUFF, the first thing I'll say is I'm not really too good with that yet. I'm still in the learning process of all that, so I mean, take this with a huge grain of salt. I'm no by no means an expert at this, but if I remember correctly, you can't verify a contract that's been written in HUFF, right? So that's one thing to definitely think about. Yeah, Ars, do you have anything to say?
Oh yeah, I'm also not an expert in HUFF or Viper, but I think Viper has some like good security stuff that Solidity doesn't have. And yeah, I don't know. I think in the future we will see some protocols being rewritten to Viper HUFF, but as we've seen with the Uniswap V4, maybe.
And
Do
also,
you see a potential? Oh, sorry. I just wanted to say, do you see a potential issue there with Huff and Viper? And I mean, obviously, I mean, even in this group here of people who know Solidity quite well, probably Huff is not our strongest. I see over here Huff is awesome in the comments, so maybe Om's over here, but nonetheless, my point being, Solidity is a little bit easier to code in, a little bit easier to audit. And do you think it would have a bad impact in terms of security measures? Right, you go into Huff and Viper for gas optimizations, and then you get less auditors actually looking at your code.
I mean, yeah, definitely. Like, I think that security will always be the number one thing that auditors will focus on. But some protocols, I think that some good that have good dev teams, I think that will be rewritten to Viper HUFF.
Hello, good afternoon
Good afternoon.
and good day. I have two questions, but like I want to first start from like thanking you, ARZ, because when I started up, I used to like look at your tweets. I'll get paper and pen to like, because I had a hard time understanding Solidity. So like, I'll have to like write it on paper and start like debugging like how this is more gas efficient and more. And like I used to like binge your tweets to like learn. So like I want to thank you for that, your tweets. And also want to thank Dead, because like I learned from him the one way attack from his Twitter trends. So like you guys are a huge inspiration for me. So like my question starts like this, like based on how gas is going in the contest, like nobody cares about gas. Like the contest, even Sherlock, they'll tell you they don't want like Watsons to like focus on gas. They wanted to find mediums and highs. Like, do you think it's better to be a private, like how Pashov is like a kind of private auditor where like Harrison, where you have to meet protocols and protocols will give them your project, like their code base, so you can optimize the amount of money you make from gas, rather than submitting gas issues. Like you waste a lot of time gathering the gas issues like from the contest with like let's say like 3,000 lines of code. Then you waste a lot of time and they pay you like a little amount of money. And they have bots where bots like find everything easily. So like that's the first question. Like, which is better? Is it like to be hunting on contests where they don't care about what you're doing and like try to build yourself on Twitter where you can get the whole issue, the money in a huge like in a high amount? And my second question would be like, based on how gas is, like the readability makes it harder to understand what a function does. Like, do you think it's better for a protocol to like do a gas optimization before they do an audit? Because I think gas optimizations like bring in bugs after like after you like if you finish auditing and now do gas optimizations later, like it brings in bugs. And I don't know how to like put the question, but like which one do you think is better, like having a gas optimization on a code base before or after doing a high level audit? It's like that's my question. Thank you.
Oh, thanks for the kind words, by the way, and great questions. So the first question, I would say that the problem is that Code Arena doesn't have a big pool for the gas optimization, right? But still, the competition there is kind of low. The contest that I did, the juice box, it had only like 11 submissions for gas, so that's quite low. And I know a guy that only does gas optimizations on Code Arena, and I think he earned like $3,000 already. So you can still earn something, and obviously the protocols will pay you more if you actually just perform like a gas audit only. But it depends. You have to deliver real results, right? You can't just say uncheck this block and then charge 30 ETH. But I believe if you do private audits, you can basically use the gas reports sort of to be unique, right? So many people just offer security audits, but you can offer both, and that will make you unique, and then the payouts will be bigger. Well, what do you think, Dad?
So so for the first question, I would say Code Arena and Sherlock are great for entry level auditors, right? There's no check. You don't need to be popular. You don't need to find customers. You can learn. You can submit nothing, and nothing happens to you. They take all the liability, et cetera, et cetera. So Code Arena and Sherlock are really good for starting out. Now, with that being said, obviously, I think we've discussed quite a few of the issues there, and I think I have not really done any private audits, so I can't really speak to this from experience. But just by looking at what I'm seeing in my DMs, because I have had projects reaching out to me and such, that it would be a lot more lucrative to be in private auditing. But as ours said, you can't just give them an unchecked blocks and charge 30 ETH. You need to really deliver results, and it's going to be a lot more work. Liabilities on you, et cetera, et cetera. So, I would say for the first question, you're better off starting off with Code Arena and Sherlock. Use those bugs and everything to get better, to get on the leaderboard, get on Twitter, start telling people what you found, and really genuinely try to help people, the other auditors. And these protocols will eventually realize that, and when the time is right, they'll reach out to you, and you can start doing your private auditing at that point. That's my roadmap.
Yeah, definitely. And the second question, I would say that first perform a gas audit and then a security audit, because as we said, that it may introduce some security risks. So it would be better to perform a gas audit and then a security audit.
I've been seeing more and more people coming up with gas platforms. I think right now, Jay Treeley, Harrison, I think some people are working together on the platform for that. And we're now trying to go over this lady doing a code review, and it's just so hard to audit this gas stuff, and I was even talking with VX. Most of some of the very complicated algorithms have been inspired by C implementations and so on, but yeah, it's hard to audit that on the EVM.
Yeah, definitely, because not everyone knows Yule and Assembly, right? So there are many more devs that just know Solidity, and it's harder to audit than if not enough people know Assembly.
What is the coolest gas optimization?
Oh,
That's a good one. I really like bit shifting and all of that personally.
Bit
I
shifting?
really bit shifting, anything with bits. I had one Twitter post where I optimized some. If you had like some UINT 8 mapping to a bool, right, you could just instead use a UINT 256, and each one of those slots would represent one of those booleans, right? Because UINT 8's max number is 255. So yeah, something like that. I really like those, and I really like anything that involves math. Obviously, my background's in mathematics,
Nice.
so anything where that optimization comes in is fun.
When we use bit shifting, it's usually for typecasting, right? When trying to convert different types, right?
Bit shifting wasn't the best way to say it. I was just saying dealing with bits in general.
Okay.
Probably said. But bit shifting is whenever you want to just shift these bits. So if you have one bit in your 0 slot and you move it to the first slot, it's the same thing as multiplying it by 2, and you can do the same thing in the opposite direction for dividing, for example. But there's also places where it's not just 2, and you have a nice even number like a 10 or 100, and you can use it for something there. Potentially, not always. But definitely if you're dealing with the multiplier, divide by 2. Yeah.
What about you, RZ? What is the coolest gas optimization?
dude, I don't know, to be honest. I kind of hate bits, but you can save a pretty decent amount of gas there. So yeah, I don't know.
Awesome, bros. Awesome. This is really interesting, and I've been seeing this smart implementations. We just had a talk with Zero Wage, and we went through, the fine line between readability and gas optimization. But also gets me a bit confusing because we're now walking to layer twos. Now we have stuff like it subscriptions. So we have different ways of, you know, passing data around. It seems to me like this gas optimization is a really momentary trend on the EVM.
What do you mean by that? By momentary trend?
I mean that right now we care a lot about reducing gas because the network fees are really expensive, but now we're coming with new layer 2 solutions. We're coming, the Ethereum is on this roadmap is walking to become cheap at some point in the future, but ideally we're gonna start using, different networks before. So if you're not paying that much for the transaction itself, maybe doing the optimization is not so worth it.
Yeah, and that's nothing new. I mean, even back in the 90s and 80s and so forth, they had optimizations for codes that today we don't think about optimizing, in Python or whatever, because our hardware has advanced so much. It's potentially possible. I mean, I wouldn't be surprised, but at the same time, as Ars was saying, we only have a limited amount of computational capacity. So unless that changes, I would assume that it's always a necessity.
Awesome. Guys, you guys have questions?
Okay, thank you very much. You answered me correctly.
Thanks, guys. It has been really insightful.
Yeah,
Thank you so much.
I really enjoyed it. I learned a lot.
Thank you, guys.
This will be.
That's why I didn't ask any questions, because I was just receiving.
Yeah, and it's a really good, a really good guide into how to start looking and diving into gas. And I'm gonna make a really nice thread about this. Thank you so much, guys. You have any closing thoughts?
No, just thank you for listening. Thank you for having us.
Yeah, thanks. Thank you very much to Dead and Miss. Thanks for hosting this, and thanks everyone for coming.
Thank you so much,
I hope
guys.
that you learned something.
We learned a
Hang
lot.
around, guys.
See you guys around.
Just hang around, brother.
Bye bye.
Thank you so much.
Thank you, guys.